10.5 to 10.6 area parallelograms, trapezoid, rhombuses, and kites. I can find the area of parallelograms, trapezoid, rhombuses.
Excellent. Thank you, Leah. Are you guys able to do that now?
Yes.
Sweet. All right, we're going to try to get through this video in 5 minutes or less. That's my goal. Parallelogram. Opposite sides are parallel and trapezoid, really quick. In a trapezoid, the parallel sides represent the
Bases.
and then the area between the bases is the height. Is that important to know?
Yes.
Yes, because when you plug in your formula, you could definitely use that information. A rhombus is just like a square, except for it's a smush square, right?
Yes.
Which we call a rhombus, but it also looks like a girl's best friend, lady's best friend.
Diamond.
Diamond. My wife's best friend, I guess. Don't mean to stereotype. Kite. Yes, no?
Yeah.
Okay, what are these two lines that are crisscrossing non-consecutive vertices?
Diagonals.
Is it important to know diagonals?
Yes.
So the difference between a rhombus and a kite is rhombus has all congruent sides. A kite has adjacent congruent sides. Yes, no? Okay, parallelograms. Area of a parallelogram is the exact same as the area of a or a rectangle. And the reason that is because in a parallelogram, I'm just going to redraw one here. In the area of a parallelogram, this is the height, right?
Yeah.
And if we chop this triangle off on top, could we just reinsert it down there?
Yeah.
Yes, and then if you take a look at this entire shape, it is a rectangle, right?
Yeah.
Therefore, they have the same area. Trapezoids, the base of the trapezoid are the parallel sides, yes, no?
Yes.
Okay, so then what you do is you add up the bases, multiply them by the height, and divide by 2. We cool with trapezoids?
Yeah.
And the reason I'm skimming through that so fast is because we've already done it in Wake Up. Pythagorean theorem, the formula for Pythagorean theorem is go.
A squared plus B squared equals C squared.
And the A and B represent what part of a right triangle? And the C represents the
Hypotenuse.
excellent. And this would be your example of that, right?
Yes.
Excellent. And Pythagorean theorem only applies to what kind of triangles again? Right triangles. Okay, so 13, we solved one, yes, no?
Yes.
So we plugged in a 3 and a 4 for the A and the B, right?
Yes.
And we squared them, yes, no?
Yes.
C squared, we don't know because that's what we're trying to solve, right?
Yes.
We squared it, we got 25, and then we did the square root of both sides. Yes, no?
Yes.
And the square root cancels out the square. So we got C equals 5, yes? Okay. Moving on to number 14, we solved this one algebraically. In this situation, we had to solve for b squared, right? So we had to follow our algebraic process here by getting the b alone, yes, no?
Yes.
Okay. And we ended up with 4 on that one. And then kites and rhombuses. What's the formula to calculate the area of a kite and rhombus on the count of 3? 1, 2, 3.
Diagonal 1 times diagonal 2 divided by 2.
And is this right here a diagonal?
No.
Is this?
Yes.
Because they are connecting
Consecutive sides.
vertices. Not sides, not consecutive vertices. All right, so 16, there's an example of a rhombus. B, there's an example of a kite. And why is it really important that I gave you an example like this where we had 2 and 7 as our one diagonal, and then I only gave you 3 here? Why is that important? It's kind of a bad question, sorry. Don't we have to add up the whole entire diagonal, right? And because this side is congruent with this side, we know that that has to be a 3 as well, right?
Yes.
Cool. And then last one, letter C. In this situation, we need to figure out what. We knew this one was a 7 and a 4, right? This diagonal. But we needed to figure out what B was. And a lot of you got stuck here. But what you fail to realize is that this, I'm going to get a different color, this right here was a right triangle. And we knew that this was 4 and we knew this was 6. So all we needed to do was solve for that B there, right? Remember that?
Yeah.
That was so much fun. So then we did the Pythagorean theorem thing over here, right? And then we plugged in whatever this measurement was right here, and we put it there as well because they're congruent. And then we solve for the area of that kite. Yes, no?
Yeah.
Questions, comments?